Hello everyone, and welcome to lesson number 7 of my deep learning course. In this lesson, we will talk about the most used activation function and how to implement them from scratch. So, without further ado, let's get started. Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description. Welcome back everyone. In this tutorial we will see the most used activation functions, we will understand how they work, and then we will implement them from scratch in our neural network. You will find the link where to download this Jupyter notebook in the video description as always. If this is your first video that you're watching from my series, I recommend to go to lesson 1 where I explain how to set up the Jetson Nano for deep learning, and then from then you can follow along and program from the web interface. As always, you will find the video of this lesson here inside the Jupyter notebook as soon as it goes online on YouTube. Then I will replace this link and it's gonna be lesson 7 and not lesson 5 like here. If you guys are not subscribed to my channel, please subscribe and activate the notification bell so that you will be updated every time I upload a new video. So let's start as always with a question. Why there are so many activation functions? So you might be wondering why there are so many activation functions, and the answer is simply improvement. Each time a new algorithm comes out is because it can improve the performance of a neural network for a specific problem. So now let's see other 3 activation functions, and these are the most popular ones. So we will start from the rectified linear unit, or ReLU for short, where the output is simply the maximum value between 0 and the input that it received. So the problem here is it cannot process negative values. Then we have leaky ReLU, which has 2 possible outputs. One is that in case the input x is positive, then the output is equal to the input. In case the input x is negative, then the output is going to be some alpha value times the input. Notice that alpha is a constant in this case and is usually set in a range between 0.1 and 0.3. The problem is that the value of alpha is fixed because it's a constant, and it has to be specified when building the neural network. Then we have the parametric ReLU, which looks exactly like leaky ReLU, but we have to notice that alpha in this case is a learned array with the same shape as x, so same shape as the input, and it is learned along with the other neural network parameters. So we don't have to set it up, it is going to learn by itself. We can set the initial values, but then the neural network figures out by itself what kind of variable, so what kind of value it has to have. So let's start, as always, to import the necessary libraries and to make sure that this Jupyter notebook is using TensorFlow 2 virtual environment. If you guys get any error, you can go up here and switch to TF2. So as always, we have a lot of information collected so far. So let's visualize those 3 functions all together. The input, as always, is are 100 points equally distributed between -10 and 10. And then we have ReLU, leaky ReLU, and parametric ReLU. For the alpha value of leaky ReLU activation function, I've used 0.2. And for the alpha value of the parametric ReLU, I have chosen values randomly. So as you can see in this line here. So if you look at the graph, we can see the blue line is the ReLU, then the orange one is the leaky ReLU, and the green one is the parametric ReLU. So the first thing we can notice is that all functions overlap when the input is positive. In case the input is negative, then we see a different behavior. So in the case of ReLU, it's simply 0, so it doesn't process a negative input. In case of leaky ReLU, we multiply that constant by the input value, so we can get some information also out of negative values. And then for the parametric ReLU, we get this kind of strange polylines. And this is because the alpha values are for each, the shape is the same as the input. So each data point has its own alpha value. So those are values chosen randomly. In this case, of course, we can set it with a specific value, but those values are going to be learned during the training. Now let's implement all these functions into our multi-layer neural network from scratch. So this class has few changes respect of the one to lesson 6 and can be summarized as follows. So point 1, it has 3 new activation functions, of course, so the 3 that I just explained. Then point 2, the constructor now accepts a new parameter to select what activation function to use after each hidden layer. So we can just say, okay, which activation function should we use after each layer? So not maybe one layer uses a certain activation function and another layer another activation function. And the reason is to simplify a little bit the code. Later on, we will also modify this class accordingly. Third point is that it has a new function that returns all the trainable variables to simplify the training process, because the difference is that now this neural network class contains more functions that help us to train, including the training itself. So instead of having functions around, we have a class with all the information, and then we just access those functions within the class itself. Point 4, this class now has a new function that updates all trainable variables to simplify again the training process. And finally has 2 more functions, which is compile and train, that allows an easier way to train the network. And for people who maybe already started with deep learning, you might see, if you have used already Keras, this is going to be very similar to Keras. Not exactly like, but pretty similar when we use compile and train. So as you can see, we are here in the constructor. We have the sigmoid activation by default as an argument to the constructor, but can be also tanh, ReLU, LReLU, and pReLU. Then we have, as always, our type checking. Then here, what has changed is that we can now create alpha variables for parametric ReLU, and we initialize them with 0.2. So I don't give the possibility to the user to choose how to initialize those variables. I just by default initialize them by 0.2. Plus, we have some other variables, so to choose what kind of activation functions we want to use after each layer, the learning rate, the loss, and the activation map, so that we can map the string that we choose to the corresponding function. Then we have here the compile network. In this case, it's pretty straightforward. We just say what kind of loss function we want to use and the learning rate. So I don't give the possibility to choose a different optimizer, like for example in Keras. Here we will stick with stochastic gradient descent. Then we have the function to get the trainable parameters and also another function to update those parameters. This is the same loop that we had before. The only difference is that if we have some alpha values for the pReLU, then we also update these alpha values here in the loop. Else is like before, so we update only weights and biases of the network. Then if we scroll down, we have, as always, the sigmoid function like before, tanh function, and then again ReLU activation, what we learned today. Leaky ReLU, so we have the same formula here. Then we have parametric ReLU. Then we have the call function, which is the same like in the previous videos. The only thing that changes is that before we were hard coding what kind of activation function to use. In this case, we have the activation map, so we automatically choose what kind of activation to apply for the output. Then we have finally the training function, which is exactly like we had separately before as a function. Now this function belongs to the class itself. So we have for n number of steps, we calculate the loss, we compute the gradients, we update the gradients, and we do this in a loop for a number of steps as chosen here. So we can now execute this code. Then we go into the loss. The loss, as always, is the same, so mean absolute error. In future videos, we will see what other kind of loss function we can use and how then changes the behavior of the network accordingly. For now, we will stick with this. Now we can finally train our neural network using some data. This time, the expected output is going to be a simple polynomial, so like we did for lesson 6. I only changed the input values to have also, by applying this polynomial, we will have also some bigger outputs at the end for the labels. And here we create the networks with the parameters, and now with 3 lines of code, we can create an instance of the class, compile the network, and train it. So we can execute the code. As you guys can see, for this network, I've chosen to use the parametric ReLU activation function. And as you guys can see, we start from a pretty high loss, 13.59, and then it reduces until it kind of plateau again to a level of 1.0. But now when we compare the prediction between the output of the network and the labels, we can see that we are a bit far in some points, but in other points we are pretty close. And we can definitely output way bigger values respect from what we had before for the tanh, for example, or from a sigmoid. Now it's time to experiment by yourself. So as always, here you can change the parameters. So you can change activation function, learning rate, steps, number of layers, and of course how you do initialize the weights for the neural network, and then see how the network behaves. So trying also with different activation function, and as a bonus task, also this time, trying to debug the neural network to understand its limitations. And if you need help, you can find here the link to lesson 4, how to debug neural network part 1, and also lesson 5, so which is the second part on how to debug a neural network. So that's it for this video. If you guys like my content, you can support me on Patreon, where you can speak directly with me, and also I can give you advice on how to get started into this career. Another way to support this channel is to use my affiliate link that I give you in the video description for your purchases at no cost for you. Finally, another way to support me is to subscribe and share this video on social media. So I thank you for now, and I hope to see you in my next video.